let us have part 2 of our topic. Remember, we are still factorizing polynomials. So for part 2, we are going to factorize polynomials in form of ax plus bx plus kay plus kby. Now, sometimes when we are factorizing polynomials, in some situations, we need to group the terms before factorizing them. Okay? Now, for instance, we are having ax minus ay plus bx minus by. We can first group it and say that this will be ax minus ay. We have this as the first group. The second group will be bx minus by. You see that? Now, after grouping them, we go ahead and factorize each group at a go. Now, let me use a different color. It will make more sense. You will understand it very well. Let's say plus bx minus by. Okay, now we begin with this part. Now you see that the GCF is a, because you have a here and a here. So we write it as a into x minus y. Okay, now we go to the blue part. For the blue part, you see that the GCF is b, because you have b here and b here. So we write it as b into x minus y. Okay, now at this step, you see that we are having another GCF, because this will be x minus y and this is x minus y. So now we can go ahead and say that we are having x minus y, then into a plus b, a plus b, a plus b. Okay? So you see that when we first group the terms, it becomes easier for us to factorize. Also, sometimes we may need to use commutative property. When we use commutative property, we make the terms that have common factors closer. We bring them nearer to each other so that we can factorize them. So in fact, once we bring them together, it is easier for us to make a group and go ahead to factorize. Now, when we use commutative property, we bring those terms that have common factors nearer. So for instance, we can say that we have cx. This is cx. Now we look for another term that has either c or x. Now you can see this is dy, we cannot take that. So let's take this one, because this is dx, it has got x there. So now we are going to have plus dx. You see that? Then after that, we can get this term dy. So we take it as plus dy plus dy. Then we get this one plus cy plus cy. Now you see that these terms that are having common factors are brought nearer. Now from there, we can make a group. We say that we have this group and then this group. Now we go ahead and do what we did here. Okay. Now you see that the GCF is X. You have X here and X here. So you write that as X into C plus D plus the GCF here will be Y. This is Y and this is Y. So we write that as Y into D plus C. You see? Now we write it as C plus D, because you see that this is C plus D and D plus C. These are the same. When we say C plus D, it is the same as D plus C. Okay, let's write it to have them in the same order. So we say that we have X into C plus D plus Y into C plus D. Okay, now we take C plus D as the common factor. So we say that we are having C plus D into X plus Y. And this becomes our answer. So you see, when you first use commutative property, it becomes easier. And now, sometimes we need to change the operations. We need to change the operation sign. Sometimes when it is minus, it will be plus, and sometimes when it is plus, it can be minus. Let's look at that using this example. When we have H into X minus Y plus K into Y minus X. Now, we cannot have, because you see this is X, this is Y, and this is Y, this is X. Yes, we see Y and X and minus, but the order is not the same. This is because when I have 3 minus 2, it is not equal to 2 minus 3. They are not equal, so we cannot say that X minus Y is the same as Y minus X. But if it is plus, no problem. C plus D is equal to D plus C. Like if I have 3 plus 2 is the same as 2 plus 3. So for plus, no problem. But for minus, you have to be careful. Otherwise, you need to change the operation sign. Now we can say that we are going to rewrite it and change the operation sign so that we get the same order. So we say that this is H into X minus Y. Now this plus, we will write it as minus, okay? Then K into, now here we are free to change the order to have it as X minus Y, okay? To change this order, you need to change this sign. If it is plus to become minus, and if it is minus to become plus. Now, when we reach at that step, you see that here we have X minus Y, and this is X minus Y. So we can go ahead and say that our final answer will be X minus Y into H minus K. We have it factorized. Now let's apply this in these examples here. A, we have number 1, A into 2x plus 3 plus 2 into 3 plus 2x. Now note one thing here. This is 2x plus 3, but this one is 3 plus 2x. Now, these are the same because we are using plus, no problem. We can swap the positions of 3 and 2 without changing this sign. We don't have to change this sign, okay? Because 3 plus 2x is the same as 2x plus 3. So we rewrite it and say that we are having a into 2x plus 3 plus 2 into 2x plus 3. So what we are doing, we are trying to put them in the same order to have 2x plus 3 and 2x plus 3. Okay, now at this step, you see that this is 2x plus 3 and this is 2x plus 3. So we go ahead and have our final answer as 2x plus 3 into a plus 2. So this becomes our factorized polynomial. Okay, let's go to part 2. For part 2, we are having 2b into 5x plus 2 minus 5x plus 2. Now, this one is okay because this is 5x plus 2 and this is 5x plus 2. So 5x plus 2 will be our GCF. So we say 5x plus 2. Now into 2b minus, now this is 5x plus 2 and this is 5x plus 2, which is our GCF. So since they are the same, we simply write 1, okay? We consider it as 5x plus 2 divided by 5x plus 2. Okay, now this becomes our answer. Part 3, we have 3c into x minus y minus 3d into x minus y. Now look, this is x minus y and this is x minus y. So that is okay. So we are going to have it as 3c minus 3d into x minus y. We write it once. Okay. Yeah, one more thing that you need to know, here the order does not matter. Okay. We can swap the sides, no problem. Like here, 2x plus 3 into a plus 2 is the same as a plus 2 into 2x plus 3. No problem. Even here, 2b minus 1 is the 2b minus 1 into 5x plus 2 is the same as 5x plus 2 into 2b minus 1. The order doesn't matter. Okay, so here we write it as 3c minus 3d into x minus y. Now, like I have told you, you need to be careful. At every step, you need to check if it has been factorized completely. Don't stop without checking. Now, when you look at this, we are having a common factor. This is 3 and this is 3. So once we stop here, it means that we have not finished for sure. Now, we will go ahead and say that we are going to have 3 into c minus d. Then this part is factorized completely. That is okay. Now, don't forget to say into x minus y. So this becomes our final answer. The last part, we have got h into x minus 2 plus k into 2 minus x. Okay, so the problem is, you see, this is x minus 2, but this is 2 minus x. That is the problem. These two things are not the same. I told you that with minus, I've told you already that if I have 5 minus 2, it is not equal to 2 minus 5. So this is the situation that we are in our part 4. Okay? Okay, so when you have minus, be careful, as I've told you. In short, when you have minus here, you need to change this operation sign. It is plus, it will be minus. So we are going to say that we have h into x minus 2 minus k. There we are free to swap the position of 2 and x. We write it as x minus 2. Okay? Now, here we have not changed the value of this term. I want you to see that if I have this part, which is k into 2 minus x, this is the same as k times 2, that is 2k, k times minus x, that is minus kx. You see, all it is the same as minus kx plus 2k, another way of writing it. Now, when I have minus k, this one, when I have minus k into x minus 2, this will be minus k times x, that is minus kx, and minus k times minus 2, that will be plus 2k. You see? Now, another way of writing this can be 2k minus kx. Now, you see that for sure that this is the same as this. So I'm doing this to assure you that we have not changed the value by changing the operation sign from plus to minus. The value remains the same. Okay, let's complete our problem. So we will say that we have, because this is already the common factor, so we say that we have h minus k into x minus 2. If you don't want to write it like this, go ahead and say x minus 2 into h minus k. It means something the same. So I believe you have understood this. One, you may need to group the terms before you factorize. Two, you may need to use commutative property just to bring the terms that are having common factors close to each other for factorization. Number three, you may need to change the operation sign, as we have seen in this example. I believe you have understood. Now, go ahead, you go to page 8, you do practice. So thank you for joining our lesson today. We meet again next time. Bye-bye.